Okay, I think we are live. Hi,
Think
folks.
so.
Welcome to this first episode of the Jump the Shark podcast, where we're going to be shooting the breeze about all things cloud native and whatever other nonsense we can think about. I'm Matt Jarvis. I'm Director of Community at D2IQ. I'm joined today by my co-host, Gerred Dillon, Distinguished Engineer at D2IQ. Hey, Gerred. How you doing?
Good, thank you.
Yeah, so I told my wife we were going to do this thing on YouTube and we were going to call it Jump the Shark, right? And she was like, "Oh, that's great. It's like an educational thing. You're going to show people how to avoid making bad choices." And I was kind of like, that's not really quite what it means. The title's about when TV shows go bad, because we expect this literally to be bad. So for folks of a certain age who may not be familiar with this meme, this is about when TV shows get completely preposterous, and it all started from that clip in the title sequence there with the Fonz from Happy Days water ski jumping over an actual shark. But I reckon this show's probably jumped the shark already, right?
I mean, it is 2020, so and no. But have you actually seen the TV tropes site and gone through all the tropes? I mean, like we have an endless source of these.
Yeah,
If we
what we
pick
should
a, if we
have a
if we
new
pick a
title
trope
for
per
every
show,
week.
then we're good.
So apparently there's another phrase that I hadn't heard before called nuke the fridge, which is like about movies, when movies have gone bad, which is like that scene from Crystal Skull where Indy survives the nuclear bomb blast by hiding inside a fridge.
Oh yeah, actually, when you first sent me that, I thought it was. I don't know if you've ever played the Fallout games, but the latest one had a character named Billy who's been stuck in the fridge for like 200 years as a mutant, and so he like survived the nuclear bombs, only to become immortal inside the refrigerator, and you pull him out, and I was like, this is really weird, but that makes a way more sense.
Yeah, well, yeah, I thought Jump the Shark was probably a more appropriate name for a podcast than Nuke the Fridge. I think that's probably a bit extreme. So, Gerred, distinguished engineer at D2IQ. You were at Deis before D2IQ, right? Early contributor to Helm, co-creator of KUDO. So how did you get into like this Kubernetes cloud native thing to start with?
Yeah, so for a long time, I was a Ruby on Rails consultant, and after that, started to uh, after everyone started to have their misgivings about or rather misunderstanding how Ruby on Rails scaled, the whole microservices movement started to blow up about 10 11 years ago. Actually, I guess after than that, like 9 years ago. So I went and became an engineer at a company and helped re-architect monoliths and the microservices there, but met some ops people along the way, and everything sort of felt a little bit odd from that point forward. Like we were just rewriting all this stuff in Chef and building these distributed monoliths. So I was at a conference called GlueCon out in Broomfield, Colorado, and a guy named Solomon Hikes, a lot of people may know him, pulled me aside at GlueCon and like, hey, you want to check out something cool? And at that point, uh, he showed me Docker, and this was when Docker was written in Python. Wasn't Docker. The company was
This
DocCloud.
is, this is
And
before they actually
this is
formed the Docker company, right? Yeah.
yeah, but before the whole
Cool.
thing. And I was hooked. I came back. It's like, hey, we need to go check this out. Wasn't ready for anything, but I planted some seeds with a couple people who I've worked with throughout my whole career. Jace Dumars of Google, now of Apple, one of those people. And I ended up leaving there. I ended up coming back to work for a company named Rally, and with Jace once again. And our charter there was to build a Docker-enabled or container-enabled platform as a service that could serve in U.S. government environments, NIST
Right.
853 environments. And we succeeded in that, but it was definitely like baby's first infrastructure as a service, right? It wasn't the best thing ever, but we learned a lot. And there I managed an infrastructure engineering team of 10 people, and then ended up at Deus right after that, after Rally got acquired. And my goal there was, because I had run a consultancy in the past, and I had actually consulted with Deus when it was pre-Deus with the same team, to help them build out their field engineering side. And that was, I joined shortly after the hackathon where Helm was created, and so I helped out with Helm early out as a user, and I contributed to a whole bunch of not just Helm v1 itself, but some of the libraries that uses it. So I added into Sprague some key functions or some hashing functions and a few other things, and also just evangelized its use everywhere and used it very heavily. And then from there, I really wanted to go use it out in the field again. Went and did some Kubernetes work in very large scale environments around VR and augmented reality, and then came back and operated at another company, and then now I'm here. So a lot of things leading up to this point, both as an end user, because I did not want to get disconnected from being an end user of Kubernetes and just be a user of this whole thing, because I think that is not a great place to be in, right? When you're imagining products but disconnected from what operations people are actually doing.
Yeah, no, I absolutely agree with that. I mean, I can recognize some of those strands in my own career, that of having done, I was involved with building some early kind of proto clouds in the 2000s. Super hacky now when you think about it, VMware API type stuff and doing big, large scale automated testing on things like that. But, it's that sweet spot really between having operated distributed systems. I've worked at a lot of companies where, there can be a big disconnect between folks who are actually writing this stuff and like what it feels like on the ground. And, if you've actually run stuff, it's a very different problem space. There's a lot more variables, right, in there to running things than there is to a dev testing environment.
Yeah, yeah, of course, yeah, absolutely. I'm of the mind where if all you've done is just write code for something like this, if you're, because this is infrastructure engineering, right? But infrastructure engineering, in my opinion, has two sides, and whatever term you want to call that, the whole thing is site reliability engineering, DevOps, whatever you want, right? Those are very hotly contested phrases. But if all you've done as a good developer, for example, is work on building stuff on top of Kubernetes or building Kubernetes, the best thing I think you can go do for yourself is head off and go operate a cluster for a year, right? A little while. And then the reverse is true, right? If you're a decent enough developer, go to the product side of that for a little bit and have your experience be heard, but also gain an appreciation of what the processes are in order to actually move features forward in Kubernetes. And I don't see enough of that cross-pollination right now, right? We always talk about in the CNCF like the end user community versus the developers, and versus is not the wrong word there, but you don't hear about very many places that blend the two worlds very well, and that might be okay. But
what do you mean in terms of end user organizations necessarily contributing very much to upstream?
Yeah, because there's really not much of a huge incentive for either side to contribute. Actually, let me back that up. There's a huge incentive for product companies to try to continue building good products and trying to be a channel for end users to continue Kubernetes, right? Like the company we work at is very incentivized to take end user needs and bring those needs up into Kubernetes. Right?
Yeah, of course, like any ecosystem vendor is, right?
Of course, but if you think about it, we're not the ones on the hook with the pager up in the middle of the night seeing the failure, right?
Yeah,
we have some mechanism of that, of course, but supporting those end users. But at the end of the day, the problem you end up seeing is I was not the one on call. I didn't go see the issue. I didn't walk through the process that would have grown me as an infrastructure engineer to be able to deal with this in the future, or come up with ways or apply my engineering creativity to solve the problem. Much like on the other side, I noticed with a lot of infrastructure engineering teams from Iron and other places that I've been at, where you have 1,000 other things to work on as well, right? You're either building on an application, an API on your own, and figuring out how to deploy it, or you're building a platform so others can deploy on top of that. And the tooling you might build is a reflection of your organization, right? So it's this weird ultimate fulfillment of Conway's law, where like the infrastructure engineering program you run is like that first stop in representing what your organization ultimately looks like in the communication structure of your organization. And you're so focused on building this custom software around your community. Like Kubernetes sounds great, right? And if you're an end user, great, you can solve all these problems. But at the end of the day, a team has to go out and deploy that thing outwards. And the issue you immediately run into is, well, okay, how do I deploy stuff? Like it's what I say. It's what I say over and over again. I have Kubernetes. Now, what the hell do I do? Right?
Yeah, I mean, as an infrastructure team, I built a public cloud on OpenStack, right? And you end up with a huge amount of code that's just to do with deployment in your environment, and that's hard to manage, right? I mean, I think to one of your points about end user contributions, you do need to be an organization of a particular size before you've kind of got spare resource to be able to contribute upstream, right? I mean, we saw this in the OpenStack world that there was probably the biggest end user organizations were also pretty big contributors, I guess, in that space, because they were hitting a lot of the scaling issues. I think in some ways Kubernetes has probably benefited from perhaps being slightly more fully formed out the box than OpenStack was, right? So some of this big scaling stuff hasn't necessarily hit end users in the same way. But I think you've got to be an organization of a certain size before you can spare resource to be doing significant upstream contributions, strategic stuff, right? It takes a lot of time, it takes a lot of effort.
Well, sure. I mean, they put like the 3-year-old plus sign on the Duplo boxes, right? And then they put like 7-year plus on Lego. And
so what age should Kubernetes have on the box?
At least 8 years old. I mean, never. No, like the getting facing the facts, like getting yourself onto Kubernetes in 2020 is actually not the hardest problem we're facing today, right? Where that's a problem we were dealing with back in 2015, 2016 of, well, we have this thing, it's about to hit 1.0. What the hell do we do now with it, right? And then I think we're getting to the point where we've solved, to some level of solved, the getting an individual cluster problem. And you've got a lot of organizations, including D2AQ, VMware, others, trying to solve that multi-cluster problem. That's fine. My concern right now is you look across this entire environment and no one asks what's next. Like what like we've created this weird perverse inverted relationship where all of us are trying to convince each other that all you need is 30 ops engineers and your problems go away. and no one's thinking about the 2 applications developers who actually have to go deploy the thing onto the thing.
Well, and who are the actual point of running infrastructure to start with, right?
Yeah. And
we've been having this conversation with people for about a decade that, unless you're an infrastructure provider, you really shouldn't be caring about infrastructure, because
well, yeah, exactly.
YouTube.
Exactly. Who's thinking about the poor Ruby on Rails developer? I shout internally about like who's thinking about the Rails guy? Like everyone's like, oh, Rails, right? Like, but seriously,
No, I
who
agree. I'm agreeing with you.
who like we need to think about the person who's actually like it. We're in a very fortunate position where we are selling a product that helps people, but the people we're helping are ultimately cost centers in companies, right? But arguably we're helping putting up more guardrails around those things, and I where my perspective and I focus very heavily on operators. Focus very heavily on workloads. I want to help the people who are actually delivering things that provide value to their organizations, no matter the technology, but right now on top of Kubernetes, right?
Yeah, I mean, there's an argument to be said that we should be looking at designing software that looks a lot more like Heroku, right?
I fight for that argument all the time, right?
And Kubernetes looks nothing like Heroku.
Well, I helped work on Deus Workflow. Like Deus Workflow was a Heroku-like, and it's still there. It has there's a fantastic team who's gone and continued working, like continuing that legacy of it. But Deus Workflow, which is now called Hephy, Hephy, is now a spiritual successor to Deus Workflow that preserves that Git push, and I have a workflow developed, right? And the amazing thing about it is you don't have to talk to your platform team, you don't have to talk to your ops team. You just go deploy Deus Workflow or Hephy, and guess what? My team's doing Git push to Kubernetes, and I don't have to think about or care what anyone else is doing. And that is one of the amazing things about Kubernetes. I think a lot of people have forgotten or didn't think about much in the first place was great. I want this. I want a Heroku-like approach to my stuff. Did I have to even talk to my ops team to be able to deploy Deus Workflow / Hephy out there? No, of course not. Like, boom, done, and they're wondering why I'm using up 10 gigs of RAM and 8 vCPUs. That's about the only thing they care about. But I can bring that into my app level. So I would like to see that return, because I do think 2015, 2016 was too early of a time, 2017 early, for something like workflow to shine. Because Helm came out. Helm is a package manager. It's not a deployment tool. I'll say that live. Like there's other people in the Helm team that will echo that sentiment. That is the official sentiment. It's not a deployment and management tool. It's but Deus Workflow was, right, and Build Packs is another sort of packaging tool. In Draft, if you think about what Draft is, for those who don't know, Draft is a tool that allows you to have a PaaS-like workflow on top of Helm charts, right? And so that is a really cool thing about Draft is that is under talked about. I think Draft is well under talked about in our industry, much like Deus Workflow was. I want to get back to focusing on how do we get the value. And it sounds so businessy when I say it, but like, how do we take the value driving parts of our business as an end user company and really focus on them? Because Kubernetes, in my mind, was ultimately meant to help standardize and shrink the operations footprints on companies, not as a mechanism to tell you that you need SREs embedded in every team, and you need a central team of 50 SREs and a platform team and an infra team and an ops team just so you can get your damn Rails app out to production. Like that like we need to get out of that insanity.
This happens with all complex distributed systems, right? Because you start off with one particular goal, and then you need to be the generalized solution, and so you end up having to scaffold in all this other stuff that maybe only a tiny percentage of people actually need, but all of a sudden 2 years down the road, the thing's got tons of features and everybody has to care about them.
Yeah, and who are doing all that complexity for, right? Like that complexity, and I don't mean to denigrate any of that, because that complexity is there, and that complexity allows a lot of flexibility that others wouldn't have. But that complexity is for ops teams, infrastructure teams, the teams that are well versed in distributed systems, who know what they're getting into. And one of the things I lament, and this gets into like one reason I wanted to create KUDO, and I'm thinking towards these workloads, is, again, if I'm putting out my REST API, if I want to deploy a REST API right now onto Kubernetes at a large span of end user companies, the program at that company is going to be trying to tell you and I, if you and I are infrastructure engineers there, that or no, we're gonna end up telling them, hey, great, you want to deploy an API, fantastic, go write your Docker file. So now you need to go learn Docker, and I need you to write your Kubernetes spec for it. So now I need to go learn a deployment, what a pod is, what a replica set is, what the deployment is, what a service is, what an ingress is. And God help you if you're running Istio or Knative in the mix, because now you're like, hey, guess what? You can do A/B testing. You're like, man, I just need to deploy as fast as I can. And
well, perhaps this is a good point to kind of segue onto our chosen topic for today, as we're talking about application deployment. And,
I know, right? I could rant about this all day.
So we're actually going to talk about operators. Perhaps we should kind of start from the start, for there might be folks listening who maybe aren't too familiar with what an operator is. So what's your definition of what an operator is?
Sure. So this is unofficial. I chair the operating working group in the CNCF, and we're working through to help officiate that. But my definition, personally, very much matches up with the original CNCF definition and the Kubernetes definition on the docs, and that is, it is an application, or a controller for Kubernetes that declaratively or takes a declarative specification and uses that to run an application with very application domain specific knowledge. And there's a bit of word soup, but
that's a lot of words.
A lot of word soup. Let me back up. I didn't have time to prepare that definition, obviously, but the focus there is domain specific knowledge, right?
Yeah.
And I've talked about this at a lot of other places, Kubernetes podcasts, and a few other talks. We're going very deep detail about this, but I won't today. But what I mean by domain specific knowledge is, to back up first, Kubernetes is a level triggered system, right? So you have a lot of systems out there that a change happens because an event occurs, and you respond to the event, right? Kubernetes is a level triggered system, in the sense that what the event is, that something happened in my system, and I, as the responder to that event, need to go react to the new level or the new declaration of what something should be. And this is the concept.
So then you have this reconciling process that, get me from where I am right now to what this event.
Yeah, exactly. And going back to like what that means, like these are terms originating out of digital signal processing, right? So if you're thinking about voltage moving through the wire, I can either respond to the change in the event, the change in voltage, or I can respond to that new voltage. And Kubernetes responds to that new voltage because the benefit there is, as things change, it's always trying to reconcile towards a new state, right? And we get to that reconciliation loop that you just mentioned is, okay, what is the mechanism by which I move to that new level? And that's the reconciliation loop. And in Kubernetes, it's very generic, right? That we think in terms of deployments and services and ingress, and how do I move a whole bunch of things around me in order to get to that state. An operator takes that notion and applies it to an individual application, right? So an etcd operator thinks about what etcd needs to do, and if you think about an etcd cluster, well, you probably need to scale it, and you need up and down, right? In etcd, that's not as simple as adding a new replica. You have to actually call the members API and add a new member in. That's the case for a lot of complicated distributed software, right? And the original needs, as evidenced by the original operators that were written, for example, the etcd operator, came out of that use case when just changing the levels of a non-application specific concept, like a deployment or a stateful set, was not good enough, right? If I wanted to scale my etcd cluster, that's a nightmare before we had something like an operator to help us along that path.
Because there are steps that have to happen in a kind of logical way for that piece of software to continue to operate, right?
Exactly, right. Yeah, you can't just change a value and have it expect to propagate and work by virtue of normal machinery.
I go out and talk about this a lot at conferences and meetups and stuff, and there's always that comparison. These kind of applications, the other kind of application is our classic stateless web app, where we don't have to do anything to it, right? It sits behind a load balancer. If I want to add another one, I just add another one. If I want to take one away, I just kill it. But unfortunately, we're in a world of highly distributed applications that don't all work like that.
Yeah, and this is what leads to when people say that Kubernetes is not ready for stateful services. Like this is one piece of that truth, right? You have a lot of issues to deal with volumes, and we're starting to squish that out. But it's one thing to solve your volume problems, but statefulness and statelessness isn't just dependent on the fact that you have a backing data store that comes back when you restart, right? It's just not. If everyone relied on the on-disk flush for Postgres, we'd have a lot more data loss, right? Because as for example, as we've learned, even with certain cloud technologies, like an fsync does not mean fsync. It does not mean it's synced to disk, even though the kernel will literally tell you that thing has been written to disk. It's lying because the actual physical controller underneath has not actually put that onto physical media that will last until the heat death of the unit.
Yeah, and you've got so many different layers in the kernel involved in that action. From like as you point out, the hardware, the disk controller. There's so many places in the kernel where that can not have happened. I mean, there's one argument to say that do operators even solve that problem, because you really still you haven't got that total control all the way up the code path from the hardware up to the application. But
I will disagree with you. I will argue that operators are in Kubernetes are the only way to solve that problem, because we get back to that domain specific knowledge, and the only way to know what the agreed upon state of the world is, because if you think about a database, we're storing the state of some world, right? The only way to truly know that is to ask the application. Sure, the application can be wrong too, right?
Yeah.
But you can't ask the disk, because the disk may not have flushed. In Redis's case, you might be dealing with an AOF, like a append-only log, before it writes out to a synchronized RDB disk. You might only be dealing with a write-ahead log that needs to be compacted down the run, right? And so the only way is to ask, like in my opinion, and I'm not a deep expert in databases, but the state that the running application believes in is to me the most canonical state that you can get. Right. And for example, just copying out an EBS instance or any other on disk instance is not enough to have anywhere near a guarantee of the application's belief of its own state. Right. So for example, I use BoltDB in Go a lot, and it uses memory pages to write to disk, and that's fantastic. I can be generally, I have some guarantee of that going to disk, right? Because it opens a page, I'm writing to that page, and everything's good. But if my application crashes, what happens next? Like if I get a panic, do I have any guarantee, right, of what's in that database file? And we're talking about something as simple as a key value store. Like BoltDB is based on LLDB. It's pure Go implementation, right? You have a few others in that entire realm, but the only way and the recommended way in the BoltDB docs is here's a way for you to write out, and here's another repo. So people have written repos for this of streaming out your entire key store through another tool and writing that out to disk. And by virtue of the fact that you sync that and then close the process, nothing's a guarantee, but that's about as good a guarantee you can get.
It's all about that human knowledge, that encapsulating that human knowledge of how to operate that application and putting that in code in some way. I mean, I would argue that there's an awful lot of operators out there that aren't feature complete in that sense, that they do completely encapsulate and remove the need for an expert human. But
but what is that expertise, right? It's just knowing that can bite you, right? It's really like there's plenty of expert humans that work on this stuff. They're usually the ones developing it who understand this. And unless you're going to build a massive company around it, like your random database, probably you're not going to be able to document it well enough for anyone to just use and come up with those assumptions that a battle-hardened user of this database can have, right?
Yeah, because
that's really what an operator is about.
Cases with these things that you might only ever come across, once in a decade, and
Yeah. So wouldn't it be cool if you could ship your application with its own runbook? Like, wouldn't that be a cool thing?
I was just about to do that segue. So let's talk a bit about the KUDO project. I'm just going to stick the website up on the screen.
Is it going to show up on the stream? That'd be cool.
I hope so. Let's
look at that.
There we go. Okay, so KUDO, Kubernetes Universal Declarative Operator. This is an open source project started at D2IQ. So why don't you tell folks a little bit about where the project came from?
Sure. So sort of this conversation, right? So
this website's kudo.dev, by the way. I should point out, as I'm sharing a tab there and not a browser window. Kudo.dev.
Kudo.dev.
Tells you everything you need to know about the world of KUDO.
So a form of this conversation is what really kicked this off. So if you look back to D2IQ when it was in the Mesosphere days, and there's a project inside of Mesosphere that powers a lot of data services called the DCOS SDK. And if you look at what Mesos and Marathon and all these tools are, one thing about Mesos is if you want to write my Cassandra framework, my Tube framework on top of Mesos, great. You actually have to go and string together the API to build your own framework on top of Mesos in order to actually use it, right? Because
that's one of the core differentiators between the architecture of something like Kubernetes and the architecture of Mesos, is that the Kubernetes scheduler has to know about all the resources and all the workloads, whereas Mesos doesn't care about the workloads. It leaves it all to this idea of two-level scheduling, where every framework has its own scheduler that decides where workload's going to be placed.
Exactly. It's about as close to a distributed kernel as you can get, right? And hugely valuable, right? I mean, even Jess Frizzell mentioned, I shouldn't say even, but like Jess Frizzell mentioned relatively recently that...
Well, because Jeff's nice about very many things. Gerred.
If you're looking for something that is dead simple to run workloads on and works great and scale, like Mesos is one of those technologies, right? I'll have to take up that tweet for the show notes, but So anything you want to write on top is a Mesos framework, and that's great if you have a lot of resources. And I really think if you're going to use Mesos, that you really have to have an engineering team behind it to make it what you want out of it, right? It's not a framework if you just want to buy something off the shelf and get going with it. But it's infinitely more powerful in my opinion. So what the Mesosphere team wrote was the DCOS SDK, and the intent there was to provide a configurable or programmable framework on top of Mesos that you could use to gain some higher level lifecycle actions around building out software for Mesos and DCOS. So it serves as this intermediary bridge between Mesos and your domain.
Generic lifecycle actions that should pretty much apply to almost every application, right?
Yeah, exactly. Which is hugely useful, right? If you're thinking from the perspective of stateful data services, with some exceptions, I'm mostly going to have the same lifecycle actions throughout. Right? Perfect. Okay, great. So I'm going to develop all this stuff. So I was approached by a few people at D2IQ, Toby, Knop, and a few others, and we kicked off this process. Myself, Fabian Bayer, York Schott, and Toby, and Tom Runyon. We all kicked off the KUDO project to bring the same expressiveness that the DCOS SDK brings to Mesos to stateful services in Kubernetes, because we saw this operator movement growing, and the problem is if I have to write and maintain 100,000 lines of Go to get myself across the line to deploy my application, that's a really tough thing, right? If you think about all these companies that are providing the complicated services, and now you have to either write Kubernetes specific software in Go to deploy on it, or if you have to hire 3 or 4 Go developers to do the same thing, in my opinion, like, you're in trouble at that point.
Yeah, so this was going to be my next question, really, was what makes KUDO different from all the other ways to make operators? Because there's a bunch of them, right? There's operator SDK, you could do it using KubeBuilder, there used to be
controller, whatever.
Yeah. There used to be loads of different ways you could do it.
So KUDO's an orchestration tool, and KUDO's an orchestration tool that this is narrowed over time what KUDO is versus what others are. The intent behind KUDO is to take your native tooling and orchestrate your native tooling in a way that enables it ease of use on top of Kubernetes. So if I'm writing a Kafka operator, I don't need to rewrite all of my Kafka operations from Java into Go. If I'm using a MySQL operator, I don't have to rewrite MySQL dump in Go. I just use MySQL dump, right? It is the orchestration of native application components to enable those native lifecycle application or operations inside of a Kubernetes cluster, and stamp that out multiple times. It's literally shipping an application with its runbook, right? That is the intent behind KUDO. Now, to contrast with those other tools, KUDO is actually built on top of KubeBuilder, which is now part of Operator SDK. And so, none of these interact in a vacuum, and I'm very much an advocate of writing Kubernetes native software. So, we're working on better ways for KUDO to be able to interact with this entire world and bring in other operators. So, if you need to write a new primitive inside of Kubernetes, if you think about the type programming system, if you need to write a new primitive, perfect, use Operator SDK.
Yeah.
But make that reusable, right? So that's something that KUDO can consume it and orchestrate it alongside your application. I see too much of, the problem you run into once you start using a lot of these operators is, I have 10 operators and I have 10 different types of docs. My team also needs to run Kubernetes. My hair's on fire. We haven't solved the problem of actually running these applications when the runbook is create a new CRD. Like that's not acceptable.
Well, I guess you're also crossing domains there, aren't you? Like, if my job is to manage Cassandra clusters, then it's likely to be that doesn't necessarily involve me knowing deeply about how Kubernetes works internally, right? That's not my job.
No. I mean, unless you're trying to change careers, like no way, right? Like there's enough of a domain here. People didn't do this just for Docker. People didn't do like we used to look at these as deployment targets, right? And these companies building these services should look at Kubernetes and Nomad and DCOS as a deployment target, right? Betting your entire business on building a Kubernetes operator for it is a bad idea. And like just a bad idea, because you're still providing your database. This is not your core competency. And one of the things I talk about heavily in all this is all great. I've invested 4 developers for a year to build this operator. We're in beta now. Oh shit, Kubernetes just released 1.19 and a whole bunch of things deprecated. I need to spend another 3 months upgrading. The state of Kubernetes right now, if you're going to build something for Kubernetes, it demands full-time attention from some people. And the nice thing about KUDO is, fine, we'll be your full-time attention. Build your stuff on top of KUDO. A lot of that problem starts to go away from you for you, right? And great. Kubernetes upgrades, fantastic. We have Kubernetes domain expertise or experts using KUDO. We'll upgrade to the latest ones. We'll maintain all the deep navigation of all that. Come use these lifecycle operations and just participate in your native app way versus becoming a Kubernetes expert. Because by the time, if you're trying to build your own operator on top of Kubernetes, by the time you can become a domain expertise in Kubernetes, you know nothing about what you're programming you were doing in the first place. So you might as well now, maybe that's a great recruitment strategy, but you might as well go get a Kubernetes job by the time you're done learning it, instead of what you were trying to do in the first place.
Where do you see KUDO going in the? I mean, I guess you answered some of this. What's the immediate future for KUDO? I know there's other folks now contributing to the project. It's getting some traction. Where's KUDO going like this year?
Sure. So we're entering the CNCF sandbox. We have the sponsors necessary to do so. So we're just figuring out the right next steps to finalize that process. We are attempting to 1.0 by KubeCon Boston at this point. It was going to be China, but China got canceled, which understandable. And our focus very much is on KUDO operators being able to respond to the world around it. So that's generating support bundles, that's custom commands for operators, it's custom plans. We have that now. It's being able to run plans in response to events within the cluster, be they cloud events or other events. And then OCI distribution and air gap is a big one. I'll come back to that. That's my personal pet at the moment that I'm working on. And other than that, we're fairly feedback driven. I really want to get to the point where we're managing schema for custom CRDs and bringing those in, or dynamic CRDs, so that people can brand their KUDO operators however they want. That's an area we need a lot more feedback in. We are also looking at doing a dynamic security model so that KUDO is only as permissive as you install operators and use the CLI to install operators. That's an area we need more feedback in. Have gotten some feedback in. So really shaping everything up to be used in large environments that really need operators, where they're deploying multiples of these at scale, and wanting to ensure that the full lifecycle of the application is shipped to end users. So from the operator working group side, we're looking at the operator maturity model that's been set forth from operator framework, and everything that needs to happen to get to a level 5 mature operator. So basically on autopilot, that's our focus right now. We're not going to hit every one of those points, but we're going to hit the main use cases that we hear about and end up being able to quickly implement. So one restriction we have there is we're very end user focused, and so if something really hurts the end user, we're going to pause and think about a new API before we do it, because there's always a workaround in core KUDO. In core of KUDO right now, you can sort of do anything, right? It's a generic way to run workloads, but we think about our abstractions very carefully. And choosing the right abstractions so that people don't have to go under the hood that often, or be very annoyed with what we do. So, but the big one that I'm working on right now is OCI distribution. And so this is the idea. Open Policy Agent does this, or ConfTest does it with Rego policies. And that is the ability to push in a KUDO operator to any OCI hub. So Docker registry, Azure Container Service, hopefully eventually Docker Hub and ECR and GCR. And as part of that, that will also help solve our air gap strategy. So the idea being is when we go to build a container for, say, Cassandra, and we'll build it in air gap mode, it'll pull down all the requisite images, pack those all into the same OCI bundle, so that when you go to deploy that into an on-prem environment, you have one tarball, right?
You've got one tarball bundled together. Yeah.
KUDO unpacks that into that environment and then rewrites all the images so that you can be air gap in one command, right? And because one of the issues I see is everyone has their bespoke commands to go in registries and everything else to go do air gap, and I think KUDO solving air gap will really help a large group that's trying to really solve this problem.
A wider group of people across the operator community than just KUDO, you mean?
Yes, absolutely.
Yeah.
So let's talk. Hopefully, we may bring that as a separate tool, or we may include it. We'll see.
Let's talk a bit more generally about operators. One of the things that's kind of interested me is how quickly this has gone from, like, we started off in this space saying, let's build a thing that just controls this one application, right? But as we all know, these things are not only complicated in themselves, but they're almost never deployed on their own, right? They're always part of a bigger application stack. So I might be using Kafka, Cassandra, a bunch of other things all tied together as a single deployment. And, I've seen a lot of folks out in the community start thinking about, how do we deploy all of these things as one thing? And, is the operator pattern like a solution to this? So, I want to deploy my entire application stack. So, maybe I should write a meta operator that controls all these other operators, because now I've got, 10 operators in my application stack. That throws up to me a whole bunch of interesting challenges, shall we say, about, how we do dependencies and interoperability and all that kind of stuff. What do you think are the kind of challenges around that?
Yeah, so I'm pausing because we do have a very large ecosystem problem right now around workloads, right? Like, solving this from the KUDO perspective, we do have a lot of we have a few operators that bring in other dependencies, other operators as dependencies. But you get into a couple problems. One, you get into a complete or total ownership of resources problem, right? If I'm running the Spark operator, which spawns up its own resources, KUDO doesn't know about those, and they can get orphaned. Beyond that, you have a large. Did you read my Twitter? Because I was yell tweeting about this over the weekend. You have a very significant problem around dependencies where you have one set of dependencies, and that's for my application, right? And that goes to your example of, well, I need Kafka for my thing to even run, so how do I deploy this? And Heroku is a great answer, right? Heroku add-ons. But then you get into these platform level dependencies, and now we're talking about things like Istio and Knative, and
I'm just reading about this.
Yeah, maybe my Prometheus stack, right? And if I have a bunch of these and I have a bunch of downstream things, like the one of the things you see with a lot of this platform level tooling is it expects to have complete ownership of that notion in your cluster. And I'm not here to argue whether that's right or wrong. Actually, I don't have an opinion on that. But the problem is like something Istio does take ownership of anything, exclusive ownership of any service mesh in your cluster, right? But it's not a straightforward task to deploy two Istio instances into your cluster, right? That situation might be getting better, but I don't know. So starting out from that assumption, or even if it was getting better, it's still a very expensive thing to stamp out multiple times in your cluster. So there's a few ways to solve that. KUDO is right now working on a dependency system. We're working a few other things around the Kubernetes operator interface, which we're calling KOI. Early stages on that, but what we're really trying to figure out is, okay, well, if I am something to be depended on, I need to be able to offer you as a dependee certain things you can consume from me.
Certain guarantees of what you can expect. Yep,
and I need to be able to offer out behaviors you can expect out of me for tooling to consume, right? So with those two things, I can build tooling around that, and I can start to depend on that. But that's still a very direct dependency, right? I'm depending on a connection string at this point, and so that's where KUDO is going today, and it's thinking of how do I create a direct dependency between Kafka and my application where I can output a connection string, consume it. Where I'm thinking in my brain's going is making this much more capability based. So I created a repo over the weekend called KubeCap, and KubeCap is an operator that is separate because I think this is useful beyond KUDO. And if I'm really preaching, if I'm really doing what I preach, KubeCap should be able to exist separately, and KUDO should be able to consume it as something where we consume interfaces. But the idea behind KubeCap is create a system where applications can declare. Actually, it's right in my description of the repo. Gerred.
You want to pull it up on screen?
Why not? Actually, no, I have not committed anything to the repo, so I won't show the description. So let's read it. I'll just read how I wrote it.
Read how you envisioned it in your mind.
Yeah. So this is it's a Kubernetes controller aimed at brokering capabilities between applications that have requirements and platforms that have fulfillments. Right. So a platform wants to fulfill the ability to provide a service mesh. And my applications, so for example, Knative is a great example of this. Knative demands having Istio as a capability available in your cluster. Because if I have 5 things that need the Prometheus operator, 5 things that need Istio, and 2 things that need Knative, those are all platform level services. And everything we do, right, or Cert Manager is another great example. Like 80 things ain't Cert Manager, right? But if I have a cluster level one, now I'm back in the weeds of having to write my own Helm chart. I have to fork everything. I have to go to stable Cert Manager. There's no isolation amongst these cluster level resources. And part of that problem is the fact that CRDs in and of themselves are not scoped. CRDs are cluster custom resource definitions in Kubernetes. If you declare a custom resource definition in Kubernetes, there's one version at any given time. That's the storage version, right? And everything else is upgraded to it. And it's a global notion. So it's like declaring a type, right? But but it is very weird that you have this type system in Kubernetes that operates in complete the complete antithesis of anything else in Kubernetes, and that leads to this restriction, right? So KubeCap is a way of thinking how do we provide requirements and fulfillments and capabilities and tie all these things together in a sane way.
I mean, it's a super complex space, though, right? I mean, from a human operator perspective, there's always kind of arguments about whether to keep your dependencies completely for this thing or that thing. If I need Postgres for this, should it have its own Postgres instance? Should I ever an infrastructure-wide Postgres. Well, what if suddenly this app needs Postgres to be upgraded and this app doesn't, and I'm kind of stuck then because, I've got all my data in one place, and it's not an easily solved problem, is it?
No, it's not. And honestly, a lot of times the easiest option is to just spin up a new cluster, right? And how do we make an incremental step for the better, or at least help the Kubernetes community demonstrate a path forward to be a little bit more robust in these large
whether you buy into the thing about one cluster to rule them all, right? Or whether you buy into this concept of like, why don't I have 500 clusters?
Yeah, and I'm very much one cluster to rule them all, right? So that very much informs my approach to these problems, because I think just because they go away, just because my problem is I'll reverse what I was about to say. Solving problems from the one cluster to rule them all standpoint is still useful to 500 clusters for maybe smaller, more broken up use cases, right? The problems aren't invisible. You've just minimized it for some local minima, right? But it's not. It has not been removed from your problem, because again, it's one thing to stand up a cluster. It's another thing to run it over a period of time and have upgrades and have an ecosystem of different software depending on different things.
Yeah.
The version of Knative you're using today is inherently tied to the version of Istio you're using, and there's no way around that. Like, period, end of story. And that's still a problem no matter what size of cluster you're using.
Yeah, that's very true. I think that's very true for a lot of systems, as a generality.
I think we have a question. If you
what?
I think we have a question in our comments.
Oh yeah, so this is from Mike Tannenbaum. Hey Mike, how you doing? Do you recommend I put my microservices in a KUDO operator along with the correct versions of my other operators? How should I think about what to KUDOfy and what not?
This is going to sound controversial. This is going to maybe not be thrilling to some people. I don't think you should KUDOfy unless you have to. Unless you have lifecycle in and of itself, I don't think you should KUDOfy an operator, like a thing, a workload just to KUDOfy it. We're working on some progressive enhancements for Helm charts, but if you're just looking to deploy a microservice, for example, and you don't have long-term lifecycle needs around it, don't wrap it in KUDO. It's not what it's for. It's for long-term lifecycle of stateful, complicated applications or orchestration of services, right? It's not for my Rails app needs to get deployed. There's plenty of mechanisms. We want to include those mechanisms as an orchestration option, but it's not in and of itself. KUDO has a templating system, but it's there for those who do not want another dependency, and that's all it's there for.
So I guess just kind of throwing some random thoughts out there. I mean, you and I have been around this space for a long time. It does feel like there's there's this continuum of kind of solving lots of the same problems, going right back to config management, Puppet, Chef, kind of stuff like Ansible. I guess even in one way you could say Kubernetes itself is like a system for how you deploy applications. But and now we've got operators that have their own controllers built into them. Should we maybe just chuck all this stuff into apps and build our applications that are platform aware? We have this stuff as a library, and then we don't need all this other stuff outside of our applications to control them.
I feel like you're predicting the next set of cycle, right? Dynamic versus static typing, and we're here, right? I don't mind that notion, but I don't think we've succeeded in it thus far. So the last opposite side of this arc, right? Because right now we're very focused around providing these as platform services. So Istio is all about taking all your network code out, right? MTLS, it's about taking out network patterns like circuit breakers and everything out of your code, which is I think an inherent good, because it separates you from having to have a bunch of middleware that does the exact same thing in your application, and you need to manage versions, et cetera, right? the reckoning with this, I predict, is that there's also a benefit to locality of that code, because you can take the same issues. Like, not every application is built the same way, right? Like, not every circuit breaker should be made equal, which is great because Istio allows you to configure that on a per virtual service standpoint, but it explodes, right? And Istio doesn't know anything about your application. So invoking, I am a huge fan of a lot of the tenets that and patterns. Well, I'm a huge Clojure fan, and when I say Clojure, like you talk about like Clojure, the pure language, and you talk about like Clojure, the way that a lot of Clojure users approach their way of solving problems. And
brackets. Brackets. That's how
Clojure used to solve
problems. Lots and lots of brackets.
Yeah, and one of my favorite libraries inside of Clojure is Integrant. And what Integrant is it is a data-defined system that allows you to separate your application into a series of components. So basically, it's a mix of, like, you have a few other things like component and mount and a few other things in Clojure that are partial, like inversion of control, but then they mix in some very Clojure REPL stuff where you can reload a component, you can stop that component, you can start that components. How do I break up my application within my own application into a whole bunch of micro services that can be started and stopped? But Integrant's a very data-driven approach, right? And so what's amazing about that is I can use data to still do the same exact thing, circuit breaker. I configure all these things that I end up wrapping my application in, right? And using metaprogramming, I can do a lot of work there to not have to worry about the domain of either writing in these components or these API level components, like these API level concerns that we would otherwise have to deal with by moving all these things out into the network. I think there's value in all that. I don't think we've all realized how much value that can have, because we're still we're still recovering from the wounds of everyone having to have, like, you break everything onto microservices, and now you have to have your God library, and every microservice has to keep up to date with God library, or you're screwed, right? We'll get there. I think it's moving towards a more data driven, and everything like that started off your question is a good movement that direction. But so now we've pulled out the data into somewhere where we can be very data oriented. If we can pull out the behavior and have it, if we can localize the behavior while staying data oriented, I would not mind to move back to locality within our APIs, instead of having all these extra steps. I think like Envoy, Envoy is really the biggest manifestation that I can think of this pattern, with Istio and Linkerd and everything else. But I'm okay with keeping, I'm okay with what that manifestation brought, but still localizing back the code. But we're not there yet. We'll see. We'll see where that goes.
No, this is a long way away.
I could be totally wrong. I'm just crazy. I'm crazy. I write Clojure, so we can leave it at that.
Oh god, it's making my brain hurt remembering Clojure. Powerful stuff, though. Powerful stuff. We built a real-time log analysis, an alerting system in Clojure for when I was running the public cloud, which worked super well. But there was nobody could ever maintain the config file. Well, the config is not really a config file, right? It's in Clojure, so.
See, but maybe if you're using Eden and Integrate, then they could have. It's years later. You should be able to revisit that now.
So one last thing before we wrap up. I know we're just over the hour here. We should definitely talk about the idea of sheet ops.
Oh my god!
It's one of the weirdest things I've seen on the internet, at least in the last 24 hours.
Did you have that? Do you have the tweet you could actually put on screen? Because
let's just put this up here.
This is like some dark horror right here.
And I think you should explain to folks what this is all about, since you could at least partially be held to blame for this abomination.
Yeah. So this happened on April Fool's Day, which I thought was an April Fool's joke, but it's real.
Yeah, I don't think it is an April Fool's joke.
No. So this is the way to control your Kubernetes cluster using Google Spreadsheets. Actually, this is V1 of this idea, and someone else went and made a V2 of this idea. And this is powered by KUDO. So what they do is the KUDO, like, they create an instance of a KUDO operator that connects out to Google Spreadsheets API. The pod connects to an individual spreadsheet, and then manages that pod and runs kubectl actions based on changes in the Google spreadsheet. And it's about as amazing and terrible as you can imagine. So there's a V2 of this where someone actually turned this into a full operator that's turned into like YAML Google Sheet Ops or YAML Excel Ops. Actually, let me not just like be horrified by, like, it's a really creative use of to be positive. Like, KUDO is really about enabling all these sorts of things to orchestrate together.
Yeah, that's very true.
And using native tooling. So it is actually the perfect use of KUDO by using your native tooling and orchestrating a whole bunch of native tools together to control a Kubernetes cluster.
See, for those of us who are of a certain age, and you may well be of this age as well, but you know, I remember the days when people used to manage their VMs in spreadsheets. You know, you'd have a spreadsheet with these VMs are on this host. You know, before orchestration systems, it was painful.
I think we need to go find the PhD CEO Twitter account and let him know. Let him know he can now control this PHP apps through Google Spreadsheets if he just uses Kubernetes and KUDO.
So I guess we're pretty much at the end of today's session. Unless you've got anything else you want to talk about, Gerred, before we wrap it up.
No, that's it. All I'll say is I am going to be streaming more of KUDO development on my Twitch stream. It's Twitch TV/JusticeFries, and enabling people to see the thought that goes into the behind the scenes. I'll be developing other stuff there. Hopefully we'll have some other people up on this show soon to chat to, and very excited. This was a blast. Thank you so much. Yeah. So
yeah, you and I are going to be co-hosting this show from now on, aren't we? So we'll be announcing lots of interesting guests over the next few weeks. So please subscribe below if you're on YouTube. You can check out our Twitter feed at WeJumpSharks. So thanks to Gerred for talking today. Thanks to any of you who did happen to listen. We seem to have got to the end without any major disasters, Gerred. So like that's something at least. And finally, thanks to our sponsors, Data-IQ, without whom neither Gerred or I could afford to sit and chat on the interwebs.